The 150 G-ton centrifuge can produce a force of 200 Gs, or 200 times the Earth's gravitation, and can spin a sample weighing up to 1½ tons. The centrifuge tests physical models of Earth structures consisting primarily of soil structures, including models of earth dams, embankments, foundations of buildings and bridges, and retaining walls.
A tactile sensor is a flexible sheet that contains a matrix of smaller sensors called sensors. High-resolution sensors are available in multiple sizes and shapes. These sensors measure the change in resistance in response to an applied load. They are used to obtain pressure, force, and the center of force. They are first attached to a handle, which cannot be submerged in water, and are then plugged into a computer running data acquisition software. They are highly flexible and may even be folded or wrapped around structures. The data is used to determine the soil pressure on structures such as footings, piles, pipelines, and retaining walls. It can also obtain the at-rest, active, and passive lateral earth pressures for a model soil. New sensors must undergo a series of steps to prepare before being installed in a model. If the sensor is to be used in saturated soil, it must be laminated with a waterproof barrier. Teflon sheeting is attached to the sensors in order to reduce shear along the face of the active sensing area. This sensor provides valuable information of soil conditions before, during, and after testing on the centrifuge. By being able to see the pressure profile on a foundation, we can determine where it is supporting the greatest load and use this information to better our understanding of soil behavior during an earthquake.
Normal cameras capture video between 24 and 30 frames per second. The high-speed camera at the Geotechnical Centrifuge at Rensselaer can record at speeds up to 90,000 frames per second. Similar to automobile crash testing, we use high-speed video to slow down catastrophic events. We can then track the motion of soil and structures in response to earthquakes, blasting, and other natural hazards. Models are constructed with high-contrast tracking targets. Specialized tracking software is used to determine their movement. Researchers use this data to determine how and why failure will occur in foundations, slopes, and retaining walls. Seismic loading on a typical centrifuge model occurs in a second or less and necessitates frame rates between 1,000 and 3,000 frames per second. As the recording rate increases, the time of exposure for each frame decreases. If we were to record a high-speed video using normal fluorescent or incandescent light, the results would be dim and difficult to track. Therefore, high-intensity LED lighting is used for high-speed video. The lights are installed on the model in order to reduce glare and shadowing while maximizing the color contrast of the targeted surfaces. The high-speed camera, LED lighting, seismic input, and other data acquisition systems are synchronized to ensure that all data